Hello everyone, welcome to Pepcoding. Today we are here to solve a question named Merge-k-sorted linked list. Okay, so in this question what we are given k-sorted linked list and we have to merge all those k-sorted linked lists and make one sorted linked list. Okay, just like in the given example, we are given three sorted linked lists and we merged all three of them and made one this which is in the output window, that sorted linked list. Okay, so let's go have a look here on the code. We are given list node class here and we have to complete this function merge k list. Okay, so here we are given a vector with filled with k linked list inside that, and we have to merge all those and return a single linked list. Okay, so first of all, let's go on the board, discuss the question. After that we will look for the solution. So we are here on the board. So first of all, we are given k sorted linked list. Let's go make a vector first. Okay, and this is the vector that we have. Okay, so now inside this what we have the head of linked list, all the linked list that is sorted we are given. So it consists of head 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 head. What is the length is k. Okay, and what is the length of every linked list is possible? Just suppose that is n, so it will be n n n, and here also, here also it will be also n n n n. We are generalizing thing, that's why we're taking n and k. Okay, so first of all, let's go and talk about the brute force approach, that if you see this question you will apply. Okay, so first of all, what we can do, all of you know that previous video we have done a question merge two sorted linked list. Okay, so we are going to use the help of that question in this question. Okay, so what we can do, we can simply take a reference node here. Okay, and what we'll do, we'll move forward, come at the 0th index of this, and what we'll do, we'll merge these two linked lists. What we'll get, we will get the same linked list that is present here. So its length is n, so it will take n time. Okay, after that what will happen, we'll come here and now the reference linked list is equals to n. Before it was equals to 1, now it is equals to length of n. Now what time it will take, it will take 2n. After that we move forward, we merge it with the third linked list. What happened, that it took 3n. After that we move forward, it took 4n. It will go so on and it will takes kn time at the last. So if we talk about the complexity, what will happen here, let me show you in the mathematical term. Okay, so first of all it takes n, after that it takes 2n, after that it takes 3n, and it goes so on, and at last it takes kn times. Okay, so now let's take n common. Now the value is 1 plus 2 plus 3 plus 4 and so on plus k. We all are familiar with the formula of adding up to k. So that is k plus 1 by 2. Okay, so this is done. If we solve this, it is around n k square plus k by 2. So simply, if we talk about in the term of O, it will be nk square. Okay, now let's go have a look on the constraint that we are given here. Here the value of k is possible from 0 to the 10 to the power 5. Okay, now let's put the value here. Okay, the value of k is 0 to 10 to the power 5, so 10 to the power 5 to the power 2, and the value of n is 0 to 1000. Okay, so just suppose it is 10 to the power 3. So what will be the complexity for this? Just see how much time it is going to take. 10 to the power 3 into 10 to the power 10, it will be around 10 to the power 13. Do you think this much complexity will do our work? It is taking too much time and it won't pass the test cases that we have here. Okay, So somehow we have to reduce this time. So we are moving forward. We have to drop this k square to k log k to solve our problem. Okay. So now let's move forward and see how we are going to do that. Okay. We are on the new page. Now let's give us a new thought. Again, we have the vector. The vector is same, but the thought is new. Don't worry, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is done. Now we all know we are having a stored head here of all the linked list. So let's do it fast. H, 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 and H. Size is N, 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 N. Okay, this is done. Now let's move forward. Talk about some other approach that will reduce our time. Okay, so first of all, what we are going to do, we are going to break this vector in two parts from mid. So let's write the index for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now what is happening? We will break it from the mid. So what happened? It will be in two parts. So 10 plus 0 equals to 10 by 2 is equals to 5. So 0 to 5 this side and 6 to 10 this side. Okay, now we move forward. Again, we break it into two parts. So what will happen? 0 to 2 this side and 3 to 5 this side. Here also we break it into two parts. So 10 plus 6 is equal to 16 by 2 is equal to 8. So 6 to 8 this side and 9 to 10 this side. Let's move forward. Yes, we break it again. So 0 to 1 this side and 2 to 2 this side. We break it again. So what happened? 5 plus 3 is equal to 8 by 2 is equals to 4. So 3 to 4 this side and 5 this side. We also break it into two parts. 8 plus 6 is equal to 14 by 2 is equal to 7. So 6 to 7 this side and 8 this side. We break this also. So it is 9 and it will be 10. Okay, now let's see here. We have 0 and 1. We have 2 here already. So here we have 3 and 4 5 6 7. So it will also break into two parts. 6 and 7 8 9 and 10. So now every what we can say, every block is divided into single parts, and each one contains one linked list. Okay, it have the 0th index of linked list, it have the first, it have the second, it have third, it have fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Okay, now let's talk about the height of this tree. Let's go and see what will be the height of this tree. Any guesses? It would be around log base 2k. Let's find out how this is log base 2k. Again, move forward. Moving forward is the process of life, man. What we can do. Okay, so what we have seen, first of all, we have k list, after that we have k by 2 list, after that we have k by 4 list, after that we have k by 8, and at last we have 1. Okay, don't you see some GP here? Okay, so now let's move forward. What we can see, can see that the ratio is 1 by 2, and the first term is k and the last term is 1. Okay, now let's find the height. How we can do that? We know the formula. A of p is equal to a into r in the power n minus 1. N is basically height, so we will denote it by p here. Okay, let's move forward now. After this, AP is 1. Okay, AN is AP here. AP is equals to 1. And AO is k. So it will be k. The value of r is 1 by 2 and the power is p minus 1. Okay, now let's move forward. If this 2 will go this side, so it will be 2 to the power p minus 1 equals to k. Take log both sides. So log 2 p minus 1 equals to k. Okay, this is done. After taking log, this side also I forgot to take log. Here it will have log base 2k. Now this will be gone. It will be p minus 1 equals to log base 2k. After that, p equals to log base 2k plus 1. So that's the height of the tree that we have, log base 2k. That's why I said. Let's have a look again. Log base 2k. Okay. Now let's see what else do we have to do. Okay. So what this diagram represents actually, let's talk about the complexity, the time complexity that it is taking. So its length is n, it is taking n time. This is also taking n time. So it will take 2n times. 2n times, right? Right. It will take n times. So this will take 3n times. Right. Good. So this will take also n times. This will also take n times. It will take 2n times. This will take n times. So it will take 3n times. It will take 6n times. Okay. And the same thing will be happening here also. So it will be also 6n. So total around, we can say 12n times takes. Okay. Now let's move forward. Okay. So what is actually happening? We are breaking the vector in two parts. And what we are doing? We are saying to the half left part, go and merge yourself. And to the right half part, go and merge yourself. What I will do, I will simply, when I will get a result from this side, I will get a one linked list. That will be merger of all those half linked lists. From the right side, what we'll do, we will get a linked list that will be merger of all those. So I have just one more. I will just merge two linked lists here. Okay, and we have done the question of merging two linked lists already. Okay, so now let's go and see. Okay, so let's go and code first whatever we have planned till now. Okay, after that we'll talk about the complexity of this solution, how it is getting reduced. Okay, so let's go. We are here. First of all, we need the code of merging two linked lists. Okay, two sorted linked lists. So we have already done that code. Let me take that code from merge two sorted linked list. Here I have the solution. No. Okay, I will have it here somewhere. Yeah, it is the Java solution. It is the CPP. Okay, I have coded here. So I'm going to take that code from this point. And list, create list, merge to list. Where it is? It is here. Okay, so I'm going to copy this code. If you haven't done this question, I recommend you please go and visit this question, solve this question. Okay, so this is the copied it. Now let's go back to our question, merge k sorted linked list. Okay, so here we are. Yes, now we have this function. What this function will do, this will simply merge two linked list. We have done that already. Okay, so now let's move forward. What we are going to do, we are going to break the given vector in two half parts. Okay, so first of all, I have to make one more function to which we will delegate our work. Let's go and make that first. List node merge k list list. Inside this, what we have a vector, left range and a right range. Okay, so vector list node and lists. Okay, this is it. Okay, and we have one starting index and one ending index. Sorry. Yes, let's make it on the full screen. It will be better. Okay, so this is done. Now let's go and see. Inside this, what we are going to do. First of all, what we have done, let me remember you. We have broken into two parts. So let's go take out the mid first. So, and mid equals to EI plus SI by 2. Okay, so this part is done. After this, what we are going to do? After this, simply we will move forward and call the left part and the right part to go and get merge yourself. Okay, so we will store that in a variable left. What we'll do, we'll make the call merge lists. Inside this, we will first pass the lists and the starting index. Starting index will be si, and the ending index for the left part will be mid. Okay. Again, we will call list node right equals to merge k list. Inside this, what will happen? We'll pass the list same, but this time the starting point will be mid plus 1 and the ending point will be ending index. This is done. So what this will do, this will give me the merged half left of the linked list, and the right one will give me the merged half right of the given vector linked list. Okay, so what I have to do, I just have to merge these two linked lists. I will get my answer. Okay, so I will return from here merge, what is the name, merge to linked list, merge to list. Okay, I have to call this function to merge them. So where we were here, and inside this I'm going to pass the left and the right. Okay, this will give me the result of two merged list. Okay, this is done. Now we have to take care of the base cases here. So what about base cases? Let's go and see here. When we started divide, when we stopped, when the starting index was equals to the ending index, right? So whenever the starting index will be equals to the ending index, that is our base case. And what we will return from here, we don't have to see anything. The starting index is also equals to the ending index, so we will return that index list only. Okay, so return list the starting index. Okay, so this part is done. Now we have to complete this function merge k list, that in which we are getting the real input from there. Okay, so let's go and see inside this what we have to do. First of all, we can check the list that we are getting, isn't it empty or so. For that, list dot size, if it equals to 0, we will return null from here. It means list is empty, it doesn't have any linked list. We will simply return null from this point, null point. Okay, now we will move forward and see. After this, we don't have to do anything. We already have make a function for the work. We will delegate our work to that function. So we will return merge k list. Inside this, the parameter, we will send our list, and starting index will be 0 and the last index will be size -1. So list dot size -1. Okay, this is done. So this is all code about. Now let's go and run this code. We have some error. Okay, this is a mistake in the snippet. We will make it good soon to run. Okay, now let's run it again. It is accepted. Now let's submit it for all the test cases. So 10 by 10. Now let's go talk about the time complexity for this solution, the solution we have applied. Okay, so let's go and take the code from here. Yeah, this was our code, right? So take it and we'll take it to the board. Okay, that is the code that we want. This is here now. Let's go. We are here. Okay. Set हो जा मेरे भाई, ठीक है. Now let's move forward. We can see here, if the total time taken by this function is t of k, what we can see, half of the time taken by this, half of the time taken by this. So it will be t of k by 2 plus t of k by 2 plus nk by 2 plus nk by 2 for all other function that is getting executed. Okay, so now let's go and calculate this, how much complexity we are having in this condition. So actually I think I have written it in the wrong space. We don't have space to write. Let me take this to some other place. Okay, let's write that first. Yes, it is here now. Now it is good. Okay, now let's calculate it. If we write k by 2, what will happen? It will be t k by 4. First of all, let's sort this out. It is little scattered. Okay, so t of k will be equals to 2 of twice of t k by 2 plus nk. Okay, so let's replace k by 2, so it will be like 2t k by 4 plus nk by 2. Again we replace it by k by 2, so it will be like 2t k by 8 plus nk by 4. Okay, this is done. So in, if we like keep it continue, so what will happen, the last term will be around t of 1 equals to twice of t of 0, yes, and it will be nk by 2 to the power something, like let's suppose p, yeah, p will be height. Okay, now we have to sum all of this. Before summing, let's make it equal to equal equation. How we are going to do that? We'll multiply it by 2, so it will be 2 to the power 2, it will be 2. We'll multiply it by 2 to the square, so it will be 2 cube, it will be 2 to the power 2. Okay, in the same way it go on, so it will be 2 to the power p, and it will be like 2 to the power p plus 1, and if we move forward, it will be 2 to the power p. Okay, so it will be cancelled out like this, and if we see these two terms are equal, so it all will be cancelled out. Okay, whatever terms comes in between, it all will be cancelled out. So what result do we get here? So it will be t of k equals to twice of t of 0 twice to the power p plus 1. Don't forget that. Okay, let me write it here, it will be more clear. So t of k equals to twice of p plus 1 t to the power t of 0 plus, it will be summation of k p times. Okay, so we are here now. Erase this part. The summation is here. Okay, so t of k will be equals to what we can say. Let's replace the value of p from the equation that we have derived. As here we can see, we have derived the value of p. What is the value of p? P is log base 2k plus 1. Okay, so we will place the value here. 2 p to the power I'm sorry, the value of p is log base 2k plus 1 plus 1 t of 0 plus n. If k is summed p times, so it will be pk, and the value of p is equals to log base 2k. So let's write that, nk, and the value of log base 2k plus 1. Okay, now let's move forward, calculate more. What will happen, we can write it 2 log base 2k into 2 to the power 2 t of 0 plus nk log, actually we can write it like nk log base 2k plus nk. Okay, so let's move forward. T of k equals to twice of log base 2k, and t of a we can write it like 4k plus nk log base 2k. Okay, so nk log base 2k plus nk. Just suppose nk by n dash, we will replace nk by n dash, so 4k plus n dash log base 2k plus n dash. Okay, so this is the final equation that we have here. Okay, now if we talk in the terms of big O, so it will be like n dash log base 2k base 2k. So this will be our complexity. N dash log 2k. Now we have replaced nk by n dash, so it will be nk log k. Okay, now let's check the time complexity for this. So the constraint was the value of k varies from 0 to 10 to the power 5 and the value of n varies up to 10,000. So it will be 10 to the power 3, k will be 10 to the power 5. Log base 2k means log base to 10 to the power 5. So it will be something like 10 to the power 8, and when it solve it, 5 comes outside. 5 into 10 to the power 8 log base 2 to the 10. When we solve this, we will get something 5 into 10 to the power 8 by 0.3 is approximate. This we will get. This much time it will take. Okay, so now let's compare what time we were having previously. Previously we were having approximate 10 to the power 13, and this time it's approximate to the 10 to the power 8. We can just say it's approximate because we have ignored some of the values here, which were nk and log k in the, when we are talking about the term of big of O. Okay, so you can see the difference here. And now this is the end of the video. I hope you have learned something. Please like and share the video and subscribe the channel. Thank you so much.